प्यारे विद्यार्थियों, तुहाडा सब दा अज दे पाठ क्वांटाइजेशन ऑफ चार्जेस विच स्वागत है। असी पहला चार्जेस दे बेसिक नेचर अते इन्हां दी प्रॉपर्टीज़ बारे पढ़िया है। इस क्लास विच अज असी चार्जेस दे बिहेवियर अते इन्हां दी होर प्रॉपर्टीज़ बारे जानकारी हासिल करांगे। अगे वधन तो पहला आओ पिछली क्लास विच असी चार्जेस बारे जो जानकारी हासिल कीती सी उस नूं दोहराइए। साडे आले दुआले मौजूद सारे पदार्थ उन्हां तत्तां दे बने होए हन जो कि पदार्थ दा सब तो छोटा भाग होंदे हन अते जो आज़ाद रह सकते हन। ए एटम्स हन। हर एक एटम इलैक्ट्रॉन्स, प्रोटॉन्स अते न्यूट्रॉन्स तो बनिया होया हुंदा है। एटम दे अंदर प्रोटॉन्स, न्यूट्रॉन्स अते इलैक्ट्रॉन्स एक दूजे उत्ते इलैक्ट्रिक फोर्स लगाउंदे हन। हर एक इलैक्ट्रॉन अते प्रोटॉन ते इक्वल अमाउंट अते ऑपोजिट नेचर दा चार्ज हुंदा है। हर एक एटम विच प्रोटोना अते इलैक्ट्रॉना दी संख्या समान हुंदी है। इस करके एटम आम तौर ते इलैक्ट्रिकली न्यूट्रल हुंदे हन। नाउ when two neutral objects are rubbed against each other, some electrons from the outermost orbits of the surface atoms of one of the objects move to the atoms of the second object. The object which gain electrons become negatively charged, while the objects which lose electrons become positively charged. This is called charging by rubbing or friction. Charging can also be done by induction and direct touching or conduction. Some general properties of charges are: like charges repel each other and unlike charges attract each other. The magnitude of the charge on the elementary particles, that is electrons and protons, is equal and its value is 1.6 into 10 raised to the power minus 19 coulombs. The electric charge in a system is always conserved. The electric charges are additive in nature. Now that the past basic knowledge about electric charges is refreshed, we can develop the further understanding of the subject. In today's class, we will study the quantization of charge and also the law governing the force of attraction and repulsion between two charged bodies. But before we start for the today's lesson, let me share the learning objectives for this class.
Learning objectives. Describe the quantization of charge. State the law of conservation of charge. State the Coulomb's law in electrostatics. Discuss the force between two charges in terms of their position vectors. Express the Coulomb's law in vector form. Solve numerical questions based on the Coulomb's law.
First of all, let me introduce you to the quantization of charge. The amount of charge on an electron or proton which is equal on both of them is known as the elementary charge. The value of this elementary charge is equal to 1.6 into 10 raised to the power minus 19 coulomb. The protons and electrons are the only charged particles constituting the matter, and hence all the charge on any object is an integral multiple of this elementary charge. Also, the charge on any object cannot be a fraction of the elementary charge. The charge on any object can be increased or decreased in multiples of plus minus e, if e represents the elementary charge. Thus, we can write an expression for a charge on an object as equal to Ne, which may be positive or negative, where n represents the number of multiples of the charge E. The fact that all observable charges are always some integral multiples of elementary charge E is known as the quantization of charge or the discrete nature of charge. We are not able to visualize the discrete nature of charge in actual life simply because the step size of electric charges is very small. Even for a small charge on an object, the number of elementary charges causing it is very large. ਮੈਨੂੰ ਇਸ ਨੇਚਰ ਨੂੰ ਇੱਕ ਉਦਾਹਰਣ ਦੁਆਰਾ ਸਮਝਾਉਣ ਦਿਓ। ਸਪੋਜ਼ ਇੱਕ ਐਬੋਨਾਈਟ ਰੋਡ ਨੂੰ ਉਨ ਦੇ ਕੱਪੜੇ ਨਾਲ ਰਗੜਿਆ ਜਾਂਦਾ ਹੈ ਅਤੇ ਇਸ ਤਰ੍ਹਾਂ ਐਬੋਨਾਈਟ ਰੋਡ ਤੇ ਤਕਰੀਬਨ 0.1 ਮਾਈਕਰੋਕੂਲਮ ਚਾਰਜ ਅਪੀਅਰ ਹੁੰਦਾ ਹੈ। ਆਓ ਐਬੋਨਾਈਟ ਰੋਡ ਦੇ ਐਲੀਮੈਂਟਰੀ ਚਾਰजेस ਦੀ ਗਿਣਤੀ ਪਤਾ ਕਰੀਏ। n is equal to 0.1 into 10 raised to the power minus 6 coulomb upon 1.6 into 10 raised to the power minus 19 coulomb, which is equal to 6.25 into 10 raised to the power 11. You can see how large this number is. Due to this large number of elementary charges causing a small charge on an object, the quantization of charge is not visible. What one get to understand is the continuous variation of charges. आओ ਹੁਣ elementary charges ਦੀ ਗਿਣਤੀ ਦੇ ਅਨੁਸਾਰ ਇੱਕ numerical question ਨੂੰ solve ਕਰੀਏ। A plastic comb is rubbed with dry hair to give it a negative charge of 5 into 10 raised to the power minus 8 coulomb. Calculate the number of electrons transferred from hair to the comb. The answer to this is the total charge transferred Q is equal to minus 5 into 10 raised to the power minus 8 coulomb, and the charge on an electron is equal to minus 1.6 into 10 raised to the power minus 19 coulomb. The formula to be used is Q equal to NE or N equal to Q by E. Thus, the number of electrons transferred to the comb is equal to minus 5 into 10 raised to the power minus 8 upon minus 1.6 into 10 raised to the power minus 19, which turns out to be 3.125 into 10 raised to the power 11. You have already learnt about conservation of charges earlier. Can you recall it? Do you remember that the total number of charges in an isolated system remains constant? The charges may get transferred during any physical process, but the net or total number of charges in that isolated system remains the same. It can also be said that a charge can neither be created nor be destroyed. We can now state the law of conservation of charges. It states that the total number of charges in an isolated system always remain conserved. Charges can neither be created nor be destroyed. Let me make this idea more strong in your minds by using some examples. When a dry plastic comb is rubbed with hair, the comb acquires negative charge and the hair acquires positive charge. The amount of negative charge on the comb is found as exactly equal to the amount of positive charge on the hair. Hence, the system of the dry comb and the hair, which had zero net charge before rubbing, still has zero net charge after rubbing also. आओ कंजर्वेशन ऑफ चार्ज ਦੇ ਨਿਯਮ ਨੂੰ ਨਿਊਕਲੀਅਰ ਰਿਐਕਸ਼ਨ ਉੱਤੇ ਲਾਗੂ ਕਰਕੇ ਵੇਖੀਏ। ਅਸੀਂ ਧੀਮੀ ਗਤੀ ਦੇ ਨਿਊਟਰੋਨ ਨਾਲ ਯੂਰੇਨੀਅਮ ਨਿਊਕਲੀਅਸ ਦੇ ਫਿਜ਼ਨ ਉੱਤੇ ਧਿਆਨ ਦੇਵਾਂਗੇ। ਇਸ ਕਿਰਿਆ ਦੇ ਰਿਜ਼ਲਟ ਵਜੋਂ ਦੋ ਡਾਟਰ ਨਿਊਕਲੀਆਈ, ਇੱਕ ਬੇਰੀਅਮ ਅਤੇ ਇੱਕ ਕ੍ਰਿਪਟੋਨ ਅਤੇ ਨਾਲ ਤਿੰਨ ਫ੍ਰੀ ਨਿਊਟਰॉन्स ਪੈਦਾ ਹੁੰਦੇ ਹਨ। ਇਸ ਕਿਰਿਆ ਦੌਰਾਨ ਬਹੁਤ ਸਾਰੀ એનર્ਜੀ रिलीज होती है। Let us have a look at the mass numbers and the atomic numbers of the reactants and the products. We will then try to find out whether the charges are conserved during the reaction or not. 1 free neutron plus 1 atom of uranium-235 gives 1 atom of barium plus 1 atom of krypton plus 3 free neutrons plus lots of energy. You can notice that before fission, the number of protons is equal to 92 plus 0 equal to 92, and after fission it is 56 plus 36, that is 92 again. Therefore, the net charge before and after the fission reaction is the same. Today, we have learnt 2 more properties of charges by now. Can you state these properties? These are quantization and conservation of charges. You have learnt some properties of charges in the previous lesson also. Let us summarize the properties of charges once again, including the 2 new properties in the list. Properties of charges. The first property goes like this: like charges repel each other and unlike charges attract each other. Second, the magnitude of elementary positive or negative charges is the same and is equal to 1.6 into 10 raised to the power minus 19 coulombs. The third property is electric charges follow the additive property, that is, the total charge on an object is the algebraic sum of the charges present on the different parts of the object. The fourth property says the charge is not affected by motion of the object as it happens with the mass. The fifth property, the charge is quantized, that is, the charge possessed by an object is a multiple of the elementary charge of an electron or a proton. The sixth property, the electric charges in a system are always conserved. We have studied about the forces of repulsion and attraction among 2 charges brought close to each other. Now, there is a need to know the magnitude, the direction, and the nature of these forces. We need to understand the factors which decide the magnitude and direction between the 2 charges. All these requirements are stated in the Coulomb's law, which was formulated by a scientist named as Charles Coulomb in 1785. Let me now introduce you to the Coulomb's law. This law states that 2 point charges attract or repel each other with a force which is directly proportional to the product of the magnitudes of the 2 charges and inversely proportional to the square of the distance between them. It is to be noted that the Coulomb's law is applicable to the charges that are point-sized and stationary in nature. If now Q1 and Q2 are the 2 charges kept at a distance r from each other, the force between them can be symbolically represented as F is proportional to Q1 Q2 and F is proportional to 1 upon r square. Combining equation 1 and 2, we can write F is proportional to Q1 Q2 upon r square, or we can write F is equal to K into Q1 Q2 upon r square, where K is the constant of proportionality and its value depends upon the nature of the medium in which the 2 charges are lying. The value of K depends upon the nature of the medium in which the 2 charges are located. It also depends upon the system of units used to measure the value of force, the charges and the distance between them. If the 2 charges are located in air or vacuum, then the value of K in SI units is given as K equal to 1 upon 4 pi epsilon naught, where epsilon naught is the absolute permittivity of the free space. Now, using equation 4, for the force between two charges located in air or vacuum, we can write F vacuum is equal to 1 upon 4 pi epsilon naught into Q1 Q2 upon R square, where the value of epsilon naught is equal to 8.854 into 10 raised to the power minus 12 coulomb square per Newton per square meter. Knowing the value of epsilon naught, we can calculate the value of the constant K used in Coulomb's law. We can now write K equal to 1 upon 4 pi epsilon naught is equal to 1 upon 4 pi into 8.854 into 10 raised to the power minus 12 coulomb square per Newton per square meter. On calculating, this comes out to be 9 into 10 raised to the power 9 Newton meter square per coulomb square. Therefore, the force between the two charges kept in vacuum can be calculated as 9 into 10 raised to the power 9 into Q1 Q2 upon R square newtons. I hope that the Coulomb's law regarding the force between two charges placed in vacuum or air is now quite clear to you. Let us now get to solve some numerical problems based on the Coulomb's law. The first problem is, calculate the force between two charge point objects having charges of 4 into 10 raised to the power minus 8 coulombs and 7 into 10 raised to the power of minus 8 coulombs, and two charges be placed 10 centimeter apart in air. The answer to this is Q1 is equal to 4 into 10 raised to the power minus 8 coulombs and Q2 is equal to 7 into 10 raised to the power of minus 8 coulombs. The distance r between the two charges is 10 centimeter in air. The formula used is F air equal to 1 upon 4 pi epsilon naught into Q1 Q2 upon R square, where 1 upon 4 pi epsilon naught is equal to 9 into 10 raised to the power 9 Newton meter square per coulomb square. Therefore, force between the charged particles in air is equal to 9 into 10 raised to the power 9 into Q1 Q2 upon R square. This turns out to be equal to 9 into 10 raised to the power 9 into 4 into 10 raised to the power minus 8 into 7 into 10 raised to the power minus 8 upon 0.1 whole square. This is further equal to 252 into 10 raised to the power minus 5 Newton, or 2.52 into 10 raised to the power minus 3 Newton. Also notice that since the force between the two charges is positive, the force between them is a repulsive force. Let us try another problem. The second problem goes like this. The force of attraction between two charged particles placed at 20 centimeter apart from each other in air is 5 into 10 raised to the power minus 3 Newton. If the magnitude of one of the charged particles is 2 into 10 raised to the power minus 7 coulombs, then find out the magnitude of the second charged particle. The solution is Q1 is equal to 2 into 10 raised to the power minus 7 coulombs. Q2 is to be found. R is equal to 20 centimeters or 0.2 meters. and the force between the two particles is minus 5 into 10 raised to the power minus 3 newtons. The formula used is F air equal to 1 upon 4 pi epsilon naught into Q1 Q2 upon R square, where 1 upon 4 pi epsilon naught is equal to 9 into 10 raised to the power 9 Newton meter square per Coulomb square. Therefore, the force between the charged particles in air is equal to 9 into 10 raised to the power 9 into Q1 Q2 upon R square. Substituting the values of Q1, R and F, we get minus 5 into 10 raised to the power minus 3 is equal to 9 into 10 raised to the power 9 into 2 into 10 raised to the power minus 7 into Q2 upon 0.2 whole square. This implies minus 5 into 10 raised to the power minus 3 is equal to 9 into 10 raised to the power 4 into Q2 upon 2, or minus 5 into 10 raised to the power minus 3 into 2 into 1 upon 9 into 10 raised to the power 4 is equal to Q2. Finally, Q2 is calculated to be minus 1.1 into 10 raised to the power minus 7 coulombs. Thus, the second charge is negative in nature. This is in confirmation with the Coulomb's law, showing that the attractive force is possible between two opposite charges. It is now turn to redefine the unit of charge in the light of Coulomb's law of charges. In SI units, the force between two charges Q1 and Q2 held at a distance r apart in vacuum is given by F vacuum is equal to 9 into 10 raised to the power 9 into Q1 Q2 upon R square. If Q1 and Q2 are assumed to be equal and R is supposed to be 1 meter, F vacuum is equal to 9 into 10 raised to the power 9 Newton. Then 9 into 10 raised to the power 9 is equal to 9 into 10 raised to the power 9 into Q upon 1 square, or Q square is equal to 1, or Q equal to plus minus 1 coulomb. Hence, 1 coulomb can be defined as the amount of charge which repels an equal and similar charge with a force of 9 into 10 raised to power 9 Newton when placed in air or vacuum at a distance of 1 meter. You all know that the force is a vector quantity. Since the Coulomb's law also talks about the forces between two charges, it can be represented in the vector form. Let us get acquainted with the Coulomb's law in vector form.
Coulomb's law in vector form. If 2-point charges Q1 and Q2 are present at points A and B in vacuum at a distance r from each other, the force between the two charges is repulsive in nature and is equal on both the charges. If F12 is the force on charge Q1 due to charge Q2, then F21 will be an equal and opposite force on charge Q2 due to Q1.
Let us apply the Coulomb's law to this situation. Magnitude of vector F12 is equal to the magnitude of vector F21, which is equal to 1 upon 4 pi epsilon naught into Q1 Q2 upon r square. This is equation 1. Let r12 be the unit vector pointing from charge q1 to q2 and r21 be another unit vector pointing from charge q2 to q1. Since the force vector F12 is along the direction of unit vector r21, we have vector F12 is equal to 1 upon 4 pi epsilon naught into q1 q2 upon r square into unit vector r21. This is equation 2. It also follows that vector F21 is equal to 1 upon 4 pi epsilon naught into q1 q2 upon r square into unit vector r12. Let us name this as equation 3. The equations 2 and 3 are the expressions of the Coulomb's law in the vector form. आओ Coulomb's law the vector form the significance जानिए. इसके दो important aspects इस तरह हैं. Since vector r12 and vector r21 are pointing in opposite directions, so equation 2, that is vector F12 is equal to 1 upon 4 pi epsilon naught into q1 q2 upon r square into unit vector r21 becomes vector F12 equal to 1 upon 4 pi epsilon naught into q1 q2 upon r square into minus of unit vector r12, which can be written as vector F12 equal to minus 1 upon 4 pi epsilon naught into q1 q2 upon r square into unit vector r12. Let this be equation 4. Combining equations 3 and 4, it can be said that vector F12 is equal to minus vector F21. Thus, firstly, in its vector form, the Coulomb's law directly shows that the two forces acting on the two charges are equal and opposite to each other. And secondly, the vector form of the law also indicates that the electrostatic forces between the two charges are central. That is, they act along the straight line joining the two charges. ਹੁਣ ਅਸੀਂ ਇਸ ਪਾਠ ਦੇ ਅੰਤ ਤੇ ਪਹੁੰਚ ਗਏ ਹਾਂ. आओ ਛੇਤੀ ਨਾਲ ਇਹ ਪਾਠ ਨੂੰ ਇੱਕ ਵਾਰ ਫਿਰ ਦੁਹਰਾ ਲਈਏ. The Coulomb's law states that two point charges attract or repel each other with a force which is directly proportional to the product of the magnitudes of the two charges and inversely proportional to the square of the distance between them. Mathematically, it can be written as F equal to K into Q1 Q2 upon R square. Here K is the constant of proportionality, which is equal to 1 upon 4 pi epsilon naught, where epsilon naught is the absolute permittivity of free space. The value of epsilon naught is equal to 8.854 into 10 raised to the power minus 12 Coulomb square per Newton per square meter. Knowing the value of epsilon naught, the value of constant K is calculated to be 9 into 10 raised to the power 9 Newton meter square per Coulomb square. The force between the two charges is equal on each charge but opposite in direction. Coulomb's law can also be expressed in vector form as well. And when expressed in the vector form, it has two important significances. These are: the first is, the Coulomb's law in its vector form directly shows that the two forces acting on the two charges are equal and opposite to each other. And the second, the vector form of the law also indicates that the electrostatic forces between the two charges are central, that is, they act along the straight line joining the two charges. So ਬੱਚਿਓ, ਹੁਣ ਤੁਹਾਡਾ ਇੱਕ ਛੋਟਾ ਜਿਹਾ ਟੈਸਟ ਲੈ ਕੇ ਵੇਖੀਏ ਕਿ ਤੁਸੀਂ ਕਿੰਨਾ ਕੁ ਸਿੱਖਿਆ ਹੈ. The first question says, what do you understand by the quantization of charges? The answer to this is, the fact that all observable charges are always some integral multiples of elementary charge E is known as the quantization of charges. The next question is, state the law of conservation of charges. An answer, the law of conservation of charges states that the total number of charges in an isolated system always remains conserved. That is, charges can neither be created nor be destroyed. The next question is, state the Coulomb's law of electrostatics. Answer, the Coulomb's law states that the 2-point charges attract or repel each other with a force which is directly proportional to the product of the magnitudes of the two charges and inversely proportional to the square of the distance between them. My next question is, state the value of epsilon naught. The answer to this is, its value is equal to 8.854 into 10 raised to the power minus 12 Coulomb square per Newton per square meter. And my last question is, if a force of 2 into 10 raised to the power minus 8 coulombs act on one of the two charges kept at a distance in space, then what is the magnitude of the force acting on the second charge due to the first? The answer to this is minus 2 into 10 raised to the power minus 8 coulombs, as it has to be equal and opposite to the first force. I hope you enjoyed the lesson as much as I did and are looking forward to the next class. Thank you for your attention and see you next time again.